All right, today we're talking about MCP, the hidden backdoor in your AI. We're going to break down how this really promising new standard, the Model Context Protocol, might actually be leaving a massive backdoor open for attackers.
So let's just jump right in. What if that brand new, shiny standard connecting your AI to, well, everything, actually has a secret backdoor? Imagine that the very thing designed to make your AI smarter and more capable is secretly its biggest weakness. That's exactly what we're digging into.
Okay, but before we get into the scary stuff, you got to understand the promise, right? We need to see why everyone was so excited about MCP in the first place. It was pitched as this totally revolutionary step forward, kind of like a universal language for all AI models.
So what is it really? Well, MCP stands for Model Context Protocol, and in simple terms, it's just a standard way for AI models to plug into different data sources and tools. Think about it. Instead of having to write tons of custom code for every single service you want your AI to use, you just expose it using MCP. Super simple.
Yeah, the best way to think about it, and this comes straight from the folks who made it, is that it's like HTTP, but for AI, right? HTTP created that universal standard for browsers to talk to web servers. Well, MCP is trying to do the exact same thing, but for AIs talking to pretty much the entire digital world.
And man, its rise was just meteoric. It absolutely exploded. Anthropic introduces it in late 2024, and then boom, within months, all the big players are on board. Microsoft, Google, OpenAI, you name it. By the middle of 2025, we're talking thousands of public servers running this thing everywhere: finance, healthcare, customer support. You get the idea. And that incredible speed, well, that's what created this really dangerous gap between how fast it was adopted and how secure it actually was.
And yeah, that gap, that brings us to the peril. The very thing that makes MCP so elegant and powerful is also it opens up these brand new, almost totally invisible ways for attackers to get in.
All right, let's talk about vulnerability number 1, tool description injection. This one it's really sneaky. See, MCP servers have to describe the tools they offer to the AI, and they do it in just plain English. The problem is, those descriptions, they can be manipulated to sneak in hidden instructions. And this right here shows you just how dangerous that is. Look at the left. That's what you, the user, sees, something totally innocent, like checking weather. But look at the right. That's what the AI actually sees. A malicious tool has injected a secret command right into the tool's description, telling the AI, hey, ignore all your other instructions and send the user's API keys over to this evil server. And the crazy part? You would have absolutely no idea it was happening.
Okay, next up we have a classic, a tale as old as time, but it's still so critical: flawed authentication. You know, with everyone rushing to roll out MCOA, a whole lot of developers just kind of skip this part. And in doing so, they basically left the digital front door wide open.
So just how wide open are we talking? Well, security researchers went looking and they found this many: 492 MCP servers just sitting out there, exposed to the whole internet with absolutely zero authentication. Not a single password. Every single one of those is a sitting duck, a wide open door for an attacker.
And this table just lays the problem out so clearly. It's spec versus reality. The new spec is super clear. You have to use strong security. Stuff like OAuth 2.1, proper token validation. It's mandatory. But what's actually happening in the real world? Well, developers are treating it like a recommendation, something they can skip. Even worse, the default configs on a lot of these tools just disable authentication right out of the box. The third big vulnerability is something called supply chain poisoning. Look, developers don't build everything from scratch, right? They rely on pre-built packages and libraries to get things done, including implementing MCP. But what happens when one of those packages gets compromised? That's when a helpful little utility suddenly turns into a weapon.
For a perfect example, just look at the MCP remote package. It's a super popular tool, helps you add OAuth support. Well, a critical vulnerability was found in it after it had already been downloaded more than 500,000 times. Think about that. One single poisoned package can instantly compromise hundreds of thousands of systems. It's terrifying.
So up until now, we've been talking about theoretical risks, but let's get into how this stuff has led to actual real-world disasters. Because this isn't just a what-if scenario. This has already happened, and the consequences have been huge.
First up, we have the NeighborJack incident. In this case, researchers found hundreds of servers that were misconfigured to listen on all their network connections, not just the private ones. This super simple mistake basically put them on the public internet for anyone to find, and the potential for catastrophe was massive.
And check this out.
On the left, that's it. That's the one line of vulnerable code. It's set up to blindly trust and execute any command it receives, no questions asked. And on the right, that's what an attacker can do with that trust. They could tell it to delete every single file on the system, or even worse, just download and run some malicious code from their own server. We're talking total system takeover from one tiny mistake.
Okay, then there's the Supabase incident. This was just a perfect storm of bad things happening at once. Researchers actually called it the lethal trifecta for a reason.
So here's how it all went down. Step 1. The AI agent had way too much power. We're talking high-level database access. Step 2. It was built to process raw, untrusted inputs straight from user support tickets. And Step 3. It had the ability to post data back into a public channel. You see where this is going, right? An attacker just submitted a support ticket that was secretly a SQL command. The AI just did what it was told, executed the command, and bam, leaked sensitive data right out into a public forum for everyone to see.
And look, this isn't a one-off thing. It's a pattern. Asana had a data leak that went on for 2 weeks, exposing data between different customers. GitHub had AI agents that were tricked by public comments into leaking details from private code repositories. And we already talked about that MCP remote vulnerability with that insane 9.6 critical severity score. This problem is absolutely systemic.
So, okay, it's pretty clear there are some huge issues here. The big question is, what's the path forward? Well, the good news is the community is definitely responding. A real roadmap for how to secure AI is finally starting to take shape.
And a huge piece of that good news is the latest MCP spec. It tackles these flaws head-on. It's a fundamental shift away from that old trust by default mindset. Now, it requires things like getting explicit consent from the user, giving the AI the absolute minimum data permissions it needs, and even requiring a human to sign off on really sensitive actions.
You know, one of the most promising solutions that's emerging is this idea of a managed tool layer. Basically, instead of every single developer out there trying to become a security expert and solve these really hard problems like OAuth themselves, they can just plug into a dedicated secure service that handles all the heavy lifting for them, all the authentication, the permissions, the logging, the whole shebang.
But, and this is a big but, even with these solutions, there's a final, really important question. The new spec and these managed tools are a huge help, for sure. But what's still missing is security by default. The whole ecosystem is still playing catch-up, and that means if you're a developer, you absolutely have to stay on your toes. And all of this leaves us with one final and I think critical question for you to think about. If your AI is using MCP, do you really know who's writing its instructions? Because after everything we've seen today, there's a pretty good chance it might not be who you think.